Hello from the Electronic Home Workshop. Today in the workshop, we are going to deal with the practical aspect of latching. Since in the first video, we deal with the theory aspect of latching, where we explained what is latching, what is tog, how to create a tog in a component in order to latch that component. But today now we are going to deal with purely the practical aspect. This is just a recap of what you will be seeing practically. Now we have a relay here, just for you to understand when you will see the component, the physical component. This is actually a relay. This box you are seeing is a relay. If you have seen a relay and observe it, you will know that most of the relays have 5 terminals. We have the output terminal, which is 2, and then we have one input terminal. This input terminal is the output of these 2 terminal. Output 1, which is normally closed, and output 2 normally open. So that if you apply a voltage here, when the relay is not energized, the voltage will move from this point to this point, thereby illuminating this lead. If you energize the relay, this pin is going to move from this point to make this contact, from contact 1, output 1 to output 2, so that the voltage you apply here will now move from this direction to illuminate this lead. Now we also have the 2 terminal here. This is the terminal of the relay, which is connected to the solenoid inside the relay, so that when you apply a voltage to these 2 terminals, the voltage will go into the relay box through the solenoid, thereby allowing the solenoid to create a magnetic force that will capable to actually attract this pin from this point, from this contact, to make this contact when you apply sufficient voltage. Now we have a capacitor is being connected to the 2 terminals of the relay, so that this capacitor will actually allow the relay to operate without making any noise. Now we have this box you are seeing here is just the rectifier. This is the AC input here, and this is the output DC, in order to convert the AC to DC that we use to actually power the whole circuit. We have the bypass, the fixed resistor here, which is 330 ohm resistor. It is there to actually allow certain amount of current to pass into the solenoid to create a magnetic force, a magnetic field with a force equals to the force of the spring. It is there to pass a certain amount of voltage. Remember, it is not going to pass a voltage that will directly switch on the relay, as we said earlier in the previous video. It is not going to pass a sufficient amount of current or voltage in order to automatically or directly switch on the relay. What it will do here is to pass a certain amount of current into the solenoid that we created a magnetic field with a force equals the force of the spring, so that a torque will be created. The bypass resistor is 22 ohms resistor. This pin you are seeing here, you can use it to connect it to the positive terminal of the rectifier, so that a current is now going to move from this point to increase the current in the solenoid or the voltage in the solenoid, so that the magnetic field will now have a greater force, that is a greater force than the force of the spring, so that the relay will now switch from this point to make this contact. And when you also remove this pin, the current will go back, or the voltage will go back to its normal stage, but this pin is already here. When the voltage or the force go back to their normal stage or normal force or voltage, this pin will not move from this point back to this point because they are equal. Now you can see the actual or the physical component that we are going to use to actually demonstrate latching. As you can see, the two lead connected to the two outputs of the relay. We have three inputs here. The two inputs here is just the input to the solenoid, and the one input at the middle is the input to these two terminal where these leads are connected. We have the bypass, the fixed resistor. This fixed resistor is just there to input a certain amount of current that will be able to create a torque in the relay. It is not there to switch on the relay directly. And this is the bypass resistor. The bypass resistor has a lead. This lead is going to connect it to the positive part of the rectifier, so that current is going to move through this point into the bypass direct to this point, to the terminal of the relay, so that the voltage here will now increase, so that the magnetic field inside the relay will now greater than the force of the spring, and then the relay will be switched on. So now let's see. Remember that this capacitor is just there to stop the relay from making noise. So let's now see how we can actually latch and see what will happen when we latch the relay on and off. Let me energize the whole circuit. But remember that this one of these leads is going to be illuminated automatically as we energize the circuit, because it is connected to the normally closed circuit. Now let's actually power the whole circuit. So that is exactly what you will see. Even when we want to latch a transistor, you will see that the moment you energize the whole circuit, one of the lead will automatically come switch on or illuminated. Now this is just a lead. I'm going to connect this lead to the positive part of the rectifier, so that current will now increase here in order to switch this relay. There is already a voltage passing through this fixed resistor here, but it is not enough to switch on the relay. It is only there to create a force that is equals to the force of the spring in order to create a torque in the relay. And now the voltage is not moving in. The torque has been already created. All we need to do is just to increase the force of the solenoid and reduce the force of the solenoid too, in order to switch on or latch the relay on and off. So now let me connect this to the positive part of the relay, to the positive part of the rectifier and see what will happen. Exactly. So now we have actually switched on this lead by increasing the voltage so that the solenoid, the force of the solenoid, will also increase so that it will switch on the relay. But the lead there is still connected to the positive. Now to the positive part of the rectifier. Now if we remove this lead from the positive part of the rectifier, thereby stopping current to flow in this direction, will this light goes off back to this point and this one will illuminated? Let's see what will happen if we remove this. Now we remove it, see, it still stay on because the forces inside are equal, so that this will not go back, switch on back to this point. So this is actually what we mean about latching. So if you want this light to illuminate, to switch off this light and this will come on, you have to reduce the force of the solenoid so that the force of the spring will be greater again than the force of the solenoid. Now how to do it? You have to take this lead and connect it to the negative part again, thereby shorting the whole current. This by this fixed voltage that is going into the relay. We have to bypass it to the ground so that there will be no voltage flowing or less voltage flowing into the solenoid, thereby decreasing the force of the solenoid, and then the force of the spring will now overcome the force of the solenoid to switch it back to its normal stage. Now let's see. See, it has switched back to its normal stage. Now let me switch it, let me latch it back. You see, I still touch it to the positive. Now I remove it, it still stay on, despite I have actually stopped the voltage from flowing into the relay. And this is exactly what we mean by latching. So we use the component relay to latch, to demonstrate latching practically. In the next video, we are going to use transistor to demonstrate latching in the workshop practically. Now thank you very much for watching the video. Don't forget to subscribe. Thank you once more again. So see the actions. So this is latching. Thank you very much.